Hello everyone, I'm Mary with Cascade Sciences, and I have with me here today Jackson Capdeville, our expert on all things distillate and isolate production. Hi Jackson.
Hey guys. Hey Mary.
How you doing, bud?
Good to see you.
Thought I'd pick his brain here today on our collection of filter reactors for making CBD isolate. We have our benchtop 5 liter, we have our 20 liter, and our Gigantor 50 liter filter reactor. Jackson, we have a few unique features about our filter reactors that I'd love to just chat with you about so that we can communicate to our customers why these filter reactors are superior to some of the lower end imported reactors you might see on the market that are being purposed to make isolate. And just at a high level, these are the same chemistry reaction systems that you're going to find in world-class pharmaceutical grade facilities. Is that correct?
Absolutely. And that, the caliber of craftsmanship that goes into the manufacture of these is what really helps make these stand apart. There are tons of different, more budget-conscious options that one could choose. But if Pfizer, Merck, or a university felt like they could cut those corners, I'm pretty sure that they would, and they choose not to. And that goes into the quality of glass that is hand blown in Japan. I mean, these 50 liters take a couple months sometimes to perfect. The craftsmanship and quality, integrity of the glass is second to none. There's an American standard of glass manufacturer, there's a European standard of glass manufacturer. The Japanese exceed both of those standards. So when you're dealing with a high value product like distillate and in conjunction with a flammable solvent like pentane or heptane or hexane, you don't want to have a mistake made. It's costly, it's potentially very dangerous as well. So using a premium grade product is going to be very advantageous for your reaction, for the safety of your customers and the quality of your product.
And very, very likely the law. Regulations are not going to loosen. They're definitely not going to loosen. And where Cascade likes to position ourselves in the marketplace is we like to sell pharmaceutical grade, certified, GMP, if you will, equipment so that when an industry that is young and growing evolves, you're already there with the equipment. So you will meet or exceed the regulations that are surely to show up at your doorstep sooner or later. When you talk about the glass, I wish this was a trade show because you can tell the quality of the glass. And one of the small points that make a big difference with this glass is the temperature delta.
Absolutely. Yeah, the temperature delta is really, really nice on this. It's over 100 C delta on this, and we can operate this within temperature ranges of down to about -90 C to plus 200 C. You obviously can't shock it to that degree with the temperature delta, but you are able to operate within these ranges. For this application, that is way more of a buffer than you're going to need. When we're talking about these isolate reactions, we're going to be pretty low on the positive C and only down to about -20 on the minus Celsius. So we've afforded ourselves a lot of temperature variance in terms of what the glass is able to handle. And you're right, like the wall thickness and the quality, it's all one seamless piece through the body. So, the more seams, the more potential failure points.
And so would you say that on some of the more lower cost reactors, your glass temperature delta would be somewhere in I've seen it about 60 C to maybe 90 C at best? The Asahi glass reactors, their temperature delta is again pushing 100 C. It's actually stamped on there, I think 110 C, but that cushion of the ability to withstand a 100°C temperature swing will forgive a lot of sins. If there's a mistake in temperature programming, or someone has a very hot reactor and dumps a very cold ethanol in there, that temperature delta will protect you from an expensive bad day.
That also goes into the training that we're going to provide with this as well. We're going to work with the customer in terms of programming their Huber temperature control unit, the recipe development, what to look for, what to troubleshoot, and then, you know, down the road, we're here for the back-end technical support as well.
Awesome. Let's also talk about the actual length of the jacket. The jacket length goes from practically the top of the reactor down to the bottom.
Mm-hmm.
Look at other reactors and you'll see that the actual jacket gets shorter because it's hard to do. It's hard to extend a jacket down to the base of the reactor and bring it all the way up to the top. But that just gives you that much more temperature efficiency and improved performance.
Oh yeah. The temperature uniformity when you can have a jacket go almost completely up to either flange is going to really aid in the process. Another thing to think about too with this reactor relative to some others that I've seen on the market is how it maintains its shape down through the PTFE filter. Other reactors that I've seen have a tendency to want to bell down to funnel things through. This is all kind of done in this PTFE filter here.
And don't be fooled by the size of the reactor. So you can actually get a lot more isolate cake out of a 20-liter reactor than you think. And the reason is how we configure the stir blade. Do you want to talk about that adjustability?
Yeah, so it's part the vessel volume shape and diameter as well. You could have the same amount of volume and a wider vessel, but when you have a slightly taller and longer vessel and volumetrics here, it affords you the ability to get higher up and still have the same reaction. How we've worked with this also, like you mentioned with the stir blade, is the stir blade can adjust. So over here, I can adjust the height of the stir blade. So relative to where my cake may be forming, I can be down in there mixing.
Okay.
As I get through it, I can pull it back up. I can mix the top. I can push it back down a little bit if I wanted to. I can use the blade to smooth the cake out for washes with the spray ball, which is located back here. You can pump some additional solvent in to wash any residual discoloration out of your isolate.
Right, in the reactor.
In the reactor, yeah. So, you know, whereas some other processes you may need to remove the cake or scoop and scrape out the isolate and then rewash it in some sort of filtration system, I'm able to do that pretty much in process here through the spray ball valve located back here. It's a little hard to see, but there's a little PTFE downspout that comes down here. It's perforated, so just sprays solvent on it, washes it down, washes discoloration out, the browns, the gunky looking color that's not this white, fine, powdered isolate, pulls that out, and then when that is all done, then we can remove safely our cake. Again, with this height and vessel configuration, we're afforded a lot more clearance in terms of how much isolate we can create. So when that would be done, then I can just simply pull the card out. Nice and easy.
Again, Cascade Sciences delivers a turnkey package, pharmaceutical grade filter reactors, and we're actually crazy enough to have them in stock. So if you are interested in learning more about these filter reactors and how they make gorgeous powdered isolate, give us a call, 503-847-9047. Contact us on Instagram or our website, and Jackson can give you all the details that you like.
Yep.
Thank you so much.
Thanks, guys.